When deciding my Masterworks topic, I knew from the beginning that I was going to do something about electricity. The real struggle was what I was going to do with electricity and what it would do to me. I've always had an interest in electronics and things I can drive around. Early on, my dad introduced me to remote-controlled devices. It became our thing. We would spend hours flying RC planes at any flat, open place. When my parents bought me a miniature ride-on Jeep, I was hooked. Later, I made a step up by buying hoverboards and electric scooters, which saved up money from my grandparents that were unhappy with what I spent their money on. In total, I wasted a lot of money on cheap garbage, and that's why I wanted to build something myself. The idea was that I would spend a quarter of the cost, and hopefully it would last a lot longer, without breaking. At least that's what I thought. I chose to electrify a skateboard because I wanted to try something new, and my previous Masterworks ideas were a little far-fetched. Hello, my name is Matthias, and this is my Masterworks presentation. In our world today, it is more important than ever to do what we can to reduce the amount of damage we inflict on the environment. Electric alternatives may not be the solution, but they're a step in the right direction, especially when most of BC's electricity is from hydroelectric power. Most other cities' power comes from burning fossil fuels, but in British Columbia, we don't, making electric alternatives way better for the environment. The average gas engine wastes most of the energy found in gasoline. Imagine an explosion. What are the first three things you think of? Personally, I think of heat, light, and sound. But the fourth product of this explosion is the physical expansion and release of high-pressure gases. This fourth and important product is what is powering your car. The leftover energy is not used in a combustion engine. And on top of that, there's 2,000 plus moving parts, further reducing the efficiency of your vehicle. Electric alternatives are safe, quiet, and more powerful. So the question is, why don't we switch to all-electric propulsion? Well, first off, it takes a lot longer to charge your battery than to fuel your car. And presently, most electric cars are more expensive. Although some electric cars are matching the price of other new cars, there aren't many options for an older, cheaper electric car that can hold up to the requirements of range and performance. So while electric cars are a good option, they're not for everyone yet. In recent years, we've made a lot of improvements in the electric car industry, and I anticipate much more in the near future. What is electricity? It's the flow of electrons in a circuit. Conductive materials like metal allow the flow of electrons, while insulative materials like rubber do not. Current measured in amps is defined as the amount of electrons that flow through a certain point every measured amount of time. Voltage is the pressure or potential difference between electrons across a source or a load and is measured in volts. A source, like a battery, is what provides the flow of electrons. This is what gives the circuit power. Resistance, measured in ohms, is like a kink in a hose, except you're draining electricity from that kink. The resistor is what converts electrical energy into usable energy. For example, a light bulb converts electrical energy into light. Electricity naturally wants to flow from one side of the battery to the other, through the conductor. In a circuit, there is a source, which is where the power comes from, and there's a load, which is what drains the power. They're connected together by wires. You can have multiple batteries powering a circuit. These can be wired in two different ways. The first is having them in series. This means that you would connect the positive terminal of one battery to the negative terminal of the other battery, effectively merging them together. In this situation, the voltage combines and you get double the power. Secondly, in a parallel battery arrangement, you have batteries side by side working together, but not adding up their voltage. You can think of it as only one battery functioning at a time. The first battery gets used, and then the second battery. In this method, the voltage stays the same, but the battery will last twice as long. I did a project about homopolar motors in science class. This isn't the motor I used, but I thought it would be helpful to add. This motor was the first ever motor to be invented in 1821 by Michael Faraday. The homopolar motor, while very simple looking, is actually quite complex. It uses the Lorentz force principle, which essentially states that if the electric current is moving through the copper wire and the magnetic force inflicted by a magnet are at around a 90-degree angle to each other, then a magnetic force will be applied to the wire, pulling one side one way and one side the opposite way. In my opinion, the homopolar motor is a fun demo to do with your kids, but has no real-world implications as it lacks any real torque and can't really power anything. Which is why the more modern electric motor is now used today in almost all utilities. In 1835, just 14 years later, two Dutchmen, Sybrandes Stratine and Christopher Becker, invented the electric motor we now use today. The modern-day electric motor doesn't use any special forces or rules other than the basic rules of electricity and magnetism. In an electric motor, there is an electromagnet, which is a magnet that is powered by an electric current. This electromagnet is made of copper wire. This copper wire is in the center of the motor and has two sides, one negatively charged and one positively charged. You can see here. One side of the copper wire is attracted to the magnet, so it spins the shaft to meet up with it. When the polarity of the wire is changed by flipping the positive and negative terminals of the electromagnet, essentially flipping the poles of the magnet, the copper wire is now repelled, and the other side of the wire is attracted. Repeat this, and you have rotation. This is what it looks like in a real motor. In the real world, electric motors are used in a number of things for a number of reasons, such as a more eco-friendly alternative to a standard combustion engine, as it doesn't release any emissions from the vehicle. Instead of using fossil fuels for its energy source, it uses batteries, which are charged by electricity. Also, the electric motor is far more compact and does not heat up as much, so it's ideal for situations like a tiny fan inside your computer when you don't want to have fumes spewing out of it. In the world of cars and other personal vehicle applications, the electric motor doesn't require a gearbox and uses much less moving parts, further reducing friction. Electric motors can have more power than internal combustion engines, making them way more fun. A battery is quite simple in its basic components. A basic battery looks something like this. The battery stores its power in chemical energy. When the battery is charged, the electricity causes electrons to separate themselves into positive and negative groups. When the battery is connected in a circuit, the electrons pass through the wire and the load to the other end of the battery, mixing up the positive and negative electrons. The battery is now dead. In order to build an electric longboard, I needed to learn how to research and buy parts, build a board, and celebrate my success. So now that you know a bit about electricity and the basics, let's get into what I actually did. I researched electric hub motors, which are just motors embedded in the wheels on the skateboard, and I found that they're usually 150 watts and 26 to 36 volts max, and around $70 each. This means that they're relatively low powered. I would need two minimum, resulting in a 350 watt total power consumption, and the cost is around $150. Then I researched external drive motors, and these range from $100 to $150. They usually take around 1,000 watts to 2,500 watts, and around 40 to 60 volts. These are about $70 each, so total cost is around $140. I went with the external motors because they cost a similar amount of money, and they're more powerful than the hub motors. My dad bought a longboard for $89. I researched how I can mount the motors to the wheels, and I found that I could buy an electric skateboard motor mount that I could attach the motor to the trucks. These things. I also did some research on the electric motors and settled on a pair of 175 kilovolt, 4,000 watt motors. I found this mounting kit online that would provide me with all the parts I needed for the motor drive system. It was $140, and at the time that seemed like too much. So I bought all the parts separately. This turned out to make it more expensive. This is a common theme in my project, by the way. Then I looked into the speed controller, which allows you to vary the speed of your board. I found a speed controller that was around $100 online. The only issue is with the cheaper ones, they wouldn't provide me with as much power. Later, I was looking into what I was going to do for the battery, and I figured that maybe I could use the battery out of my old electric hoverboard, but I soon found out that the battery is far too small and I wouldn't achieve both range and power. Then I thought maybe I'll look into a battery from a wrecked electric vehicle, and I found one. It was a battery from a Segway that had crashed, but there was something wrong with the battery that had to be fixed. I ended up not using this battery because the seller took it off their page, and since I found nothing else that could work, I started looking into building the battery myself, and I watched a few videos on the subject. I realized that the wheels on my longboard would not work for the gears and drive system, so I knew that I would have to replace them. Then I started to think about how cool it would be to have a board that could go off-road. I found a kit online for off-road wheels that have the gears and belts together with them. Here's a diagram for what goes on the board. So these are the motors, and that's the belt and the wheels, and then I didn't do a flexible battery, but there'd be a battery and then the speed controller goes around here. I bought the motors previously mentioned, and I also bought all the parts I needed to build my own battery. My batteries arrived, but it was late, so I went to bed. The next day, I glued the packs. Together, and I planned to wire these packs in parallel packs of 4, and then wire up all those packs in series. That way, I get a 12S 4P battery pack. After I glued the packs together, I spot welded the connections to make up the 12 packs. I went to Rona and got some fibrous tape that looked strong so that my battery would be protected. Then I started on the worst part of my Masterworks, which is making these painful battery connections. The way that the electricity flows is it'll go in this wire, then across through the battery, and then jump with the connection, and then through that battery, jump with the connection, and so on until you get to here. I kind of incorrectly wired the battery by accident, so the black wire is positive, and the red wire is negative. That caused many issues later, but yeah. Then my motors arrived. Oh, wait. Oh, man, I skipped some things. So here's the battery management system. There's 12 wires, but it's really complicated, so I'll keep it brief. Basically, you have to put the wires on different parts of the pack, and it's just what charges the board. This is me soldering. So I have this connection. What's happening? Anyway, so then I did that, and we put flux on it, and then I'm adding solder to it, and now I'm soldering it on, and I'm done. Then they're huge. I got these wheels called cloud wheels, and they have a foam core that provides with a lot of shock absorption, so they're perfect for a smooth ride. With them also came what I needed to build the drive system. I ordered the rest of my parts, and my motor mount came. My dad and I had a lot of problems getting everything to fit. The motors couldn't fit with the holes already drilled, so we had to make new ones. Something was always rubbing and grinding, and the motors were too big, so we had to put them in a weird configuration. You know. So at this point, everything was almost done, and all I had to do was mount everything to the bottom of the board and program the speed controller. 1 week before the Masterworks presentation, as I was programming it, my speed controller burst into flames like a NASA rocket. I'm not kidding, the resemblance was uncanny. All hope was lost, as you can see with this totally real photo of it burning. I started to think of last-minute options. It needed to be something that was already in Vancouver. And after trying many stores, I found a store specifically for electric skateboards that had what I need. So I bought the replacement and got to work soldering it up. I had one last near-death experience, and it was finished. So this is me riding it to school. Photo of me on it. Okay. This project has taken a lot of time and work. I made it seem simple and straightforward, but in reality there was a problem at every point. Pretty much everything that I bought required some sort of modification to work with the rest of the board. The battery connections really just took a lot of time, but it was more the little things, like when we would spend an hour trying to solder a connection only for it to break the next day. I think that with the help of my dad, I was not only able to complete it in time, but I was also able to keep my sanity. But when I finally finished the project, I was so glad to not have to solder any other wires ever again. And now the grand unveiling. So I added these really cool leather mud flaps, which are pretty, and then this is where the battery is. That's the speed controller, and then obviously the motors.
Please, I don't know if anyone can see this, so I'm going to hold it up. You guys have to realize how heavy this thing is.
Very. Cool, thick mud flaps. This is the battery connections. It took us like a total of 7 hours. This is the ESC, and those are the motors.
So, Matthias, how fast can this thing go?
I haven't really tested it. I went 35 kilometers an hour on it, but the remote claims that it can go 75, so I could not.
Excellent question. Is this legal?
Well, the answer is no, Matthias.
Wait, do I have more? Okay. Thank you to my dad for his creative ideas and solution making. Thank you to my mom for fronting the cost of the whole project. And thank you to my aunt for helping me present and edit this project. Additionally, thank you to Pam and Jen for being the best advisors I could have had. I couldn't have done it without your help. Also, thanks to Damien from Bowen E-Bikes and that guy at the skateboard shop. Big help. Goodbye. What do I do? I forgot to touch it. I forgot to touch the statue, but I guess maybe it's phony because I still presented without it.
Mr. Thane, hopefully touching that statue helped make this thing work. So I am so impressed with your presentation for a long, long process of finding parts, buying those parts, waiting for parts to be delivered, which was really agonizing for Pam and I and you and your family, waiting for things to happen because you were at the mercy of suppliers and delivery systems and all of that. So well done with your perseverance, especially at the end when all of the parts finally came. And it was just a couple of days ago that Matthias came on his skateboard up the road. So that was really impressive that the final push actually was super successful. So well done you. What would you think was your biggest learning experience through this?
I think learning how to make the battery, I think, was pretty cool. When I went to the shop and the guy said that it took him like 4 tries to build a battery, and my battery functions, so I don't know, I guess I'm just amazing. But also, to the people that did not think that I would finish, which is like everyone here, in your face.
So we are now ready for questions. That was my question from half of your advisory team. Pam has another question for you, and then we'll go to questions from the floor.
By the way, I think even you thought for a little while there that maybe it wasn't going to happen, so back at you. Mr. Thane, you set out to build your own board to save money and make something that would last. And you talked a lot about the cost of everything. Matthias, I'm over here.
Sorry, there's...
Yeah, talked a lot about the cost of everything. Did you do an analysis? What would it cost to buy an electric skateboard from that shop you finally found in North Van compared to what it would cost you, or what it did cost you to make your own?
Well, it really depends. Like, there's a lot of different levels, I guess. But I would say for a board of the level that I've made it, I mean, minus all the, like, oh, it might fall apart, but, you know, minus all that, like, with everything it can do, it would probably be like $3,000 new if you were to buy one.
And do you know how much you spent in the end? Did you figure out plus or minus?
Yeah, I have it. It's okay.
All right.
$750 divided by 2 times 4 divided by 8 times 4 times 2, and that is the correct number.
Would you sell this board?
I mean, I don't think anyone would buy it, but if someone's like...
I'm being serious. Now that you know how to do this, is it worth your work to actually make these and sell them? How about, would you make more money selling pretzels?
Probably.
Give me the pretzels.
The amount of
selling.
time. Yeah, I think that generally, I think it's probably, I've put in more time than it's worth. But yeah, I maybe, probably not this one. I mean, those leather mud flaps are pretty awesome.
Yeah. Well, at one point you did tell us you were going to get it done in about half an hour to put everything together. And
that was like, well, it wasn't the whole project, but from the point I think it's technically possible. It's just, you know, when you almost die, it tends to slow the production down.
Well, I was very impressed with your learning process. You're a true designer. Because to go through all the pitfalls and all the thinking and creativity that you had to have to put that together, and your understanding of electricity, I was really super impressed. So thank you.
I know that there are a lot of students
There we go.
here who are potentially thinking about making something for their Masterworks, and some grade 9s who also did. So I'm going to hand over the questions to you, Mr. Olson, to ask the first question, since you also created something.
Great presentation, Mr. Thane. I must ask, I noticed about the motors how there might be a problem with a lack of differentials on that. Do you think that could become an issue in the future, or has it been an issue?
Were you saying a lack of differentials?
Yeah, so
I know what you mean by that, but I don't know what you mean by that.
so each motor is spinning individually, correct?
Yeah, well, it's just a slight problem. I'm not sure why, but it doesn't really affect it. Because, like, yeah, as you were saying, I can show one of them spins up slow, like for the other. If I can see that. Okay.
Is there a motor for each wheel?
Yeah. Okay, well now it's working. It's really weird. But yeah, it just makes it so that it does burnouts when I'm not on it, which is honestly a plus, so.
Is that because one starts before the other?
Yeah, so it has a slight turn, which causes it to spin.
Lucas, come on up.
Okay, so I was wondering, do you think that this project was dangerous to you in any way? Building it?
So many times. When I was wiring it up the last time, the new ESC, well, like I said, because the wires are swapped on the motor, there was Well, so anyway, we were wiring positive to negative, negative to positive. It was a fair mistake, but anyway, it kind of did this big plasma arc in my face, and it was pretty scary. So, yeah.
Mrs. Zagaroni, come on up, please.
State recruitment.
Yes.
Hello.
Oh, Mr. Thane. What was one thing you could change if you could, other than the explosion?
I would say I would probably have bought better motor mounts that don't cause so many issues, because it's definitely a pain, even just to keep them up. Like, I don't know. They grind, the belt like grinds with it, and then these come off sometimes. I don't know. This whole motor mount system is kind of a pain, but I would change that, like maybe buy something.
And my second question, have you hit anyone with it yet?
Yes.
I've caused Olivia to have ankle damage, but that was actually her fault. She had the remote. So.
And your aunt.
All right. Wait, what happened with you again? Oh, right, yeah. No, I hit her ankle, but yeah.
Drove into your aunt's.
No serious damage.
Mr. Morissette.
I think you can just ask from your seat.
Oh, I was going to ask you. Oh, go ahead.
All right, Mr. Thane, that was an amazing presentation. My question to you is, what was your favorite part of like building it?
Favorite part.
Standing on it and riding it.
Yeah, riding. That's not in the building though. Oh, the mud flaps were pretty fun. I guess the battery was sort of fun to do, but in like a exhilarating, like I might die kind of way. But yeah, not much.
Okay, we have a question from your grandpa, and he's an electrician, so watch out. I think it's going to be a good one.
I'm not electric.
Mechanic.
How do you break that thing?
How do-
Stop it.
The motors have regenerative braking, which
Does it
slows
work?
you down. Yeah, it works well. So the motors brake for me.
Like, what do you do? Reverse the current?
No, well, it's just you push forward to go forward and then brake to brake.
Or you're saying that you're breaking the electricity supply.
Yeah, well, it's reversing the motor direction, I'm pretty
So it
sure.
must be reversing the current.
Also, in other
Yeah.
words, it goes backwards.
Yeah.
Electricity
Well,
goes
I guess it slows it, yeah.
And how effective is that?
Quite. I can stop pretty aggressively.
You can,
Well, actually, one of my belts is slipping, which makes me not stop aggressively, so it's kind of worrying, but it's okay. When the belts aren't slipping, then yeah, I can stop throw you off the board stop, which has happened.
Mr. Saru, come on up.
Just the grade 9s.
That was a fantastic presentation, Mr. Thane. You talked about really wanting to work with electricity. Is there anything else that you would like to put a motor on in the future, or something like that?
I like the idea of electric surfing. I think that would be cool.
Okay, next question from Lee.
Latex, yes.
Amazing presentation, Mr. Thane. Was there ever a point in your project where you just want to like smash your thing to pieces?
Many times, mostly with the soldering, because we had some failures because originally I had the wires so big and my supply of wires was like from a very bad, Rona has horrible wires, just really bad. So they were a pain to solder. And yeah, a couple times where I just kind of was like, Father, take it, do it. and or like, you know, exchange out, swap us, because it's painful. A couple times where we had to, I think it was a very effective way of doing it, where like, you know, he was a big help in this.
Thanks.
Ms. McDonald-Hewitt.
Fantastic job, Mr. Thane. Very well done. How does the brake system work? Oh, sorry, I didn't hear that.
Yeah, well, it's the brakes are just with the motors. The motors slow it down. So I guess honestly, I'm not really sure how it works, to be honest with you. But yeah, just the motors, I guess they try to spin backwards or something like that. Like it reverses the direction of the motors and I think it applies current to like slow them down. And it also charges the battery when I brake, which is pretty good.
Melanie.
Mr. Thane, excellent presentation. There's a lot of components in your product, and I'm wondering, what was the process of figuring out what you needed to make this product and what you learned about sourcing and testing those elements?
I guess I learned that not everything is compatible. Actually, nothing is compatible. I think that I learned a lot about being specific with what I find, because some of my parts were very eclectic, which did not really work for the project.
Thank you.
Mr. Thane, was there a way to figure out some of those things beforehand? Because I know you were thinking about ordering some parts and then realized that they weren't compatible.
Yeah, well, I guess I just, there was a part, it was a wheel I was going to get, and it had the same, there's the gear that slots into the wheel, and it had a part for the gear to slide in, but I realized that it actually wasn't meant for electric skateboards, even though it looked like it. So I had to look in and figured out that it actually wasn't at all the same system.
So I have a question about that. You said a couple of times you watched a video, or you tell me that you found these parts. Is there a community of electric skateboard builders out there that like to blog and post videos?
Yeah, there was definitely, I wouldn't have been able to build the battery without videos online. And yeah, there's definitely quite a lot of the following for electric skateboards. Although they're not super prominent in Vancouver.
Maybe you could become a YouTube sensation and teach people how to do this.
Yeah. That's for sure.
Go ahead.
Yes, I have two questions. One is my question, and one is from your uncle. And I was out of the room because there's no Wi-Fi or cell service in here, so it might have already been answered. So I'll just ask the two questions again. So the first one is from your uncle, who has watched this in Munich live, so that's kind of cool. So he wanted to find out whether this would inspire a follow-up project and building something else, and what might that be. Did you already answer that? Or?
Not really.
Not really? So what might that be?
I have one. I have interest in electric scooters because I have one, but it kind of broke. It's also not the best. Like one, so my dad was thinking of trying to make that work again. Yeah, and I guess. It wasn't. Yeah, I did say surfboard, but it's a little less. The budget on that is a lot higher, even than this.
The second question, or my question is, I think we talked about this earlier when you were building the battery pack, and I said, doesn't that generate a lot of heat? And did you not have to find a way to cool that battery pack? And I see that it's enclosed in this Dremel plastic kit, so just wondering how it keeps cool, or does it need to be kept cool?
It's really a question on sustainability, I guess. Like the battery, the cooler it is, the longer it lasts. But I haven't really put in much to cool it.
And you also haven't probably used it that much, right?
Yeah, I haven't. But the motors get fairly hot, but I think that's normal. The ESC does get a little hot, but I have that kind of, well, I mean, it's sort of cool, I guess. I mean, there's air brushing over it. Although the battery's actually kind of sunken into the box, so I guess there's no real cooling at all.
Yeah.
But it should be fine. I don't think it heats up that much.
Okay. Here's
Are you going to do the question?
No, you can go ahead.
Okay, thank you. Mr. Thane, that was a fascinating presentation. And what I was really impressed with was not only your technical skill that you developed to put this thing together, which to me looks like a terrifying contraption.
That's for sure.
But also the knowledge that you have demonstrated here about electricity, and you mentioned talking about electrifying our transportation grids. I've heard on the radio that's supposed to, our plan as a nation is to try and do that as quickly as possible and get there in 10 years or something. My question to you is, as you do this, do you think that's a good idea? It seems very complex and difficult. In your opinion, do you think electric transportation is the answer? Or are there pitfalls that we are ignoring?
Well, I mean, it's definitely not a perfect system. I mean, obviously there could be, really the biggest problem is just with the source of energy, I would say. It's probably like the battery or whatever is powering it. It's definitely a hard topic to get over. It's just the fact that if you have something that's electric, you're not going to be able to just go as far, and you're not going to be able to rely on it as much. Right. And there's not as much options for like, oh, I'm out of electricity, let me just zap a full tank, you know? You can't really, yeah.
Yeah, well, it's great. It's phenomenal.
And I mean, some people say, you know, electric cars are bad for the environment because the lithium that you have to mine up is a pretty rare source, and I think the mining of it is like bad for the environment, but I mean, to be honest, at this point, we kind of have to pick our battles, I guess, and, you know, obviously depleting planetary resources is not the best, but if it's, you know, that or polluting the environment further, it's, you know, what's going to kill us first, really, I guess. Haagen-Dazs.
Excellent presentation and excellent skateboard, you know, in my face. What problems did you anticipate, and did any of them come true?
Problems?
Yes.
Okay. I mean, I didn't anticipate much problems, to be honest. But I guess I was worried about building the battery because there is definitely a lot of danger there with, you know, high voltage. I think it's something like ridiculous, like 200, 300 amps or something. It's ridiculous. I don't know. It's pretty high, and the voltage is also pretty high. So, I mean, it probably couldn't kill me, but it would be pretty bad. So I guess I anticipated that something might go wrong in the battery, but nothing did. So.
I just have one simple question. You mentioned that your battery pack is being housed in a Dremel toolbox. My question to you is, where do you plan on storing your Dremels?
This is also a Dremel box. They're both Dremel boxes.
As a result, we've got Dremel bits all over the house.
Can you show us the batteries inside there?
I did epoxy it, but I'm not sure. I might be able to.
No, don't.
Oh, don't.
I didn't know.
Yeah, it's pretty sealed. But that is it. I mean, you can't really see much, just the white.
Mrs. Sandra, come on up.
Excellent job, because there's so much to this and so many little parts. What skills did you learn that are going to serve you in the future?
I guess soldering, reluctantly. It's not my favorite, but that could help me, I guess. And I guess problem solving is a big part, because there was so many different issues that we had to overcome, especially with the belts, but also with the batteries. The configuration and when I wired things wrong. Yeah.
A follow-up question is, do you think now that if your electric scooter or any future contraptions that you make or have, do you think you'll tackle fixing them if they break?
I mean, I already was, but I think now I can successfully do it, probably.
Yeah.
Wonderful job listening, Mr. Thane. I have two questions for you, but since you did so much research with circuits and electricity and everything, do you see yourself pursuing engineering, or like in the future, do you think you pursue that?
Yeah. I would say, yeah, I guess.
The question is, I've heard like soldering and stuff with wires and stuff. Maybe kind of obvious, but what is soldering exactly? We've heard very and stuff with the wires.
Well, it's just connecting wires together, or connecting wires to things with solder, which is a metal that's pliable and melts at low temperatures. So you just kind of use it to fuse wires together.
Mr. Lee, come on up.
Great presentation, Mr. Thane. I love the process, your process. There's a lot of challenges, and you all conquered it, and you conquered it really well. My question is, what do you think the limits of your skateboard is? Like terrain it can go on, and like its durability, and like how waterproof it is, or something like that. And if it isn't, are you planning to make it waterproof?
Well, on the waterproofing, I did attempt to make it waterproof, but I wrote it too soon after. And so it's not waterproof anymore. Well, it's, I guess, more waterproof, but not fully. And as far as capabilities, I haven't found a hill it can't ride up. And I mean, I'm on Bowen, so it's pretty, yeah. And the range, I think, should be pretty high, because I've been riding it around a lot, and it's only died once. And I was riding it all around school last Friday, and then home, and then all around Park Royal. So, yeah.
And what terrain do you use?
Oh, right, terrain. Well, I think it's probably not going to get over like sticks and stuff, but I think gravel, dirt, grass. Actually, it doesn't do too well on grass, but harder terrains, I think, yeah. I mean, I meant it to be sort of an all-terrain sort of thing, where you can ride it on most places. So, if a bumpy road comes up, it's no big deal. It just rides right over it.
Last question, Mr. Wing.
Are you allowed to ride it in Park Royal? Like inside the wall?
Probably not. Probably not. I'm probably not allowed to ride it, period. I mean, I don't know.